Where are the mounds? In my documentary, Erosion of Earth, I promised that I would show you using Google Earth links where all of the features I discuss are. I'm going to start off with mounds, the most widespread geologic mystery in the world. And you can see that it is very widespread and you can find them all over the world. And I'm going to show you all of the locations that I talked about and explained in my documentary. And I'm going to even show you more than that because I obviously have a lot more links and pins of mounds around the world. And after you guys watch this video, you guys are going to have an incredibly complete understanding of mound formation. And it's very important to understand mounds because they are such a great mystery and they're so widespread. Okay, so let's start off in Washington on this hillside of the east side of the Cascades. We first notice mounds kind of in a line-like pattern coming down this mountain. Okay, and then you can see how water branches and separates out the mounds. Okay, so from our first location, we get a strong impression of fluvial origin for these beautiful mound-like formations. And we also find ripples on these hillsides as well. So it's not just the streamlining shape, but we also have ripples on these hillsides that also indicate kind of a rapid fluvial origin. And we can see how it looks like water just poured and swept right across here, first making a line, and then after the water intersected and washed between it, that washing around is what creates mounds. Okay, so I need to show you guys the locations so that you guys can study them for yourself and really learn about this. But you also find them on top of mesas. Mesas are the most amazing erosional features. They're always so full of incredible stuff. Mesas are the spots, ripples, mounds. And this spot up here, this is where I got my drone footage in the video of this here. And I came down like this, and you can see, and that's when I explained how this is a water path, and these are all water paths. Okay. So the elevation of this, for example, is 824 meters. And the Washington Basin down here where the river is today is 215 meters. So we're talking about over 600 meters of elevation difference between the river and a place that shows evidence of water washing over it. So when people talk about the Washington flood and all of that stuff, they need to scale that up quite a bit once you understand mounds. So then you go over to the Oregon side, you've got mounds on terraces, right? Terraces also indicate a water level. They're basically lake shorelines. Mesas, again, have great mounds. You can see how mounds kind of formed right here. Similar to Washington, of course. This one's apparently the highest. Let's check the elevation. 13, almost 1,400 meters. So that's quite impressive. And so I want to zoom out so you guys can find that right there on that end of this tip here. But you want to find some real nice ones. This guy here. I love this spot. I mean, how beautiful is that? All of these mounds were separated and carved out and absolutely decorated the landscape. Yeah, it's another great example of them being on mesas. You find a mesa, you're going to find some cool stuff on it, I promise you. But all of these, this whole area, I mean, there's hundreds, I don't know, maybe not hundreds of miles, but a lot of square mileage of these features, all indicating water washing over and carving this dirt. So that's just something you have to understand when you talk about and when you start studying erosion. Now, this is an incredible example, but it's not even unique. You can find this in Africa, Australia, China. I'm going to show you guys how you can find stuff like this absolutely anywhere in the world. So let's go, let's just zip over here to East Africa. Let me find a good spot for you, this one. Okay, same thing. These are all mounds, and we have the same accretion ridges, lakeshore lines, terraces, mesas. See, this is a mesa. Mesas have mounds. That's an important thing to remember. And see, here's another good mesa with some nice mounds on it. I think this guy was a good shot in the video. Oh wait, no, not this one. Oh, so this is a cool spot because you've got mounds, you've got ripples. Let's peep the wavelength on these guys. 342 miles, not bad for, was this Somalia? Actually, as far as Somalia goes, that's really not that impressive. Somalia's got some nice 700 footers all over the place, but and then look at all this. See, that's all branching. These are all riverbeds, but I can't get too much into that in this video. I want to show you guys mounds. So here's a great spot. This is one of the best spots for understanding mound formation, because so many people still think they have to do with gophers, and that just grinds my gears. Because they're only studying gophers when they're looking at mounds, they're not studying Google Earth. But yeah, so you can obviously see how water came through and separated and sculpted these features here. It's all water sculpting. Okay. Oh, this was in the documentary. This is a good spot here. All right, so this is, okay, you can see drumlins, parallel paths of water current coming down here. Then on this cliffside, this mesa, we find some big mounds, and then we find smaller mounds around them. So this bigger mound here, it's just a mounded dirt, but it's perfectly symmetrical, almost 1,000 feet in diameter. And then you've got the little mounds. The little mounds are, let's measure this one, like 80 feet or so. Now these parallel lines, those are a feature I call current ruts or river scratches. Then you can also see parallel features, these being drumlins of a type. But mounds really have nothing to do with, they're really not confined with altitude, which is what makes them so puzzling. I read about this spot. This is on a mountain in Kenya, And I read about this spot making Mounds so mysterious because you've got a perfectly flat terrace, right? How do flat terraces form? If you've watched my channel, you'd know. And then you've got all of these mounds. So people are trying to figure out how these mounds get up here. Right. Well, if you understand the terrace formation, then you would start to understand the mound formation as well. And then here, this reminds me a lot of Washington, the way you get these arcing paths of water current. It's a little messy, but you can see how these are mounds. And the elevation here is 3,700 meters. So, I'm just telling you what the erosion's saying. That's all I can do, really. And show you the erosion, show you the spots for you to check them out. Let's check out this. I mean, there's so many cool spots. And obviously, I've spent way too many hours looking at mounds on Google Earth, so I thought I'd at least show you where they're at so you guys can check them out. So this actually reminds me of Kazakhstan, because this kind of looks like an egg, right? You got the yolk, and then you've got the white part around it. Right here, you got the another little egg formation. Let's get a little diameter on this guy. 6,000 feet, so that's over a mile. Okay, and now let's go to Kazakhstan to show you what I'm talking about. Where is that nice one in Kazakhstan? Oh, yeah. So same type of thing where it's, don't they kind of look like eggs? Now, of course, what's popping out to you is that there's ripples. 500 or so feet in wavelength. Pretty decent. But, like this one here, that's a perfect egg. Basically. Perfect egg. So you've got, the central mound, the outer mound, and little mounds on top of it. So this one's the perfect egg. That's right for breakfast. And then look at the mounds here. So here's another good one with some nice ripples. And then in between them, what is that, a little bit of salt scabland action? Yeah. Those are little river scours from a salty river. You know what that means? Whole area's all salty. Then you've got, mounds in the lake basins. So you could find, really good mounds in low elevation. Like this is only 75 meters above sea level. But you can also find mounds in really high elevation. So let's go back to North America, and this spot here is so sick. I believe this is Utah. I'll zoom out so you guys can see. This little ridge here, right next to this canyon, which was once a river, bank to bank. You zoom in on these hillsides. Nice mounds. Good river separation right here. Keep in mind, this is a geologic mystery no one can solve, even though it's plain to see once you have enough data, right? If you're only looking at one spot, like if you're only looking at the mounds in San Diego, for example, and you're just studying the gophers, you're not going to figure this out. But if you look, because it's the most widespread geologic mystery, you've got to check out many spots. And let's check the elevation on that one. This one's pretty high up. About here is probably where it gets the highest. 2,500 meters. Decent. Let's check out this. Find some little mounds in here. That kind of indicates that these were once canyons. Funny how you get parallel canyons all over the world. It's almost like it's indicating sheet water flow. Probably is. Check out these. Yep, we got mounds up here. 2,200 meters. I'm telling you, mesas have the mounds. That's what I'm saying. Perfectly flat mesa. I bet it's got some mounds on it. Okay, let's find. Okay, yeah, this one was in my documentary. It was green when I showed it to you guys. Now it's all covered in snow, but man, this is a great spot for mounds. You should check out my video. The documentary is called Erosion of Earth Part 1, and then I've also got a mound video called Mounds, the Greatest, or the world's most widespread geologic mystery. And I show these when they're all green. And the elevation on this one, I believe, is quite impressive. This mesa is over 3,000 meters in altitude. So how do you get water washing and sweeping off of this mesa at 3,000 meters? Well, it's the same way it got planed flat, just like a riverbed. And let's check out this point here. Yeah, so you got mounds all over the world. No one understands why. Quite intriguing stuff. So it's nice and cold up there, but it doesn't matter about altitude at all. Let's go down to Arizona. Right, obviously this is the Grand Canyon. Here you've got a real solid tributary to the Grand Canyon. Let's see if we can find any mounds. There's some beauties right here. Just like Oregon and Washington, we see the river separation, right? We can see the river path. Very cool stuff. Let's go over here, see what's going on. I've got a lot of mounds pinned, so I thought I'd show them to you. You know, it doesn't matter what state you're in, I can find a mound for you to check out. You want me to find a mound near you? Tell me in the comments. Oh, this is a cool spot right here. This isn't really mounds, but this is a really cool deposit that was pushed up against these mountains. Should talk about that soon. Let's go down farther to New Mexico. In this little salt basin. Right, there's mounds. All these salt scabs. These aren't a formation of Carolina bays. They're a feature called, that's basically, vaguely called a scour. Let's check out what we got here. Okay, mounds galore. River separation. This is New Mexico. It's really known for being a dry spot, and yet seems like water flowed right off of this hillside, just like all the hillsides in the world. Then you've got transition to bigger mounds, and then you transition to some scouring, perfectly circular scours, right? Again, that's what people mistake the Carolina Bays for. And I'm definitely going to do a video on that. Take it down to Mexico. Well, those are basically ripples. There's got to be mounds around here somewhere. There's definitely mounds around there. But let's check out this spot. I think this one was in the dock. Yeah, I wish that thing could stop saying mounds. Yes, this is a great spot here. Nice large mounds in Mexico. You can see the riverbank. And then look at all these salt lakes. How did that get there, right? You guys are going to start figuring them out once I explain to you guys more and more features. Let me just go to this spot here in Utah. So this is the Great Salt Lake. Obviously, this is pretty low to the basin level, but you can still see how water came through and made the mounds, right? So that's a good example to explain how they form. Lake Missoula. Lake Missoula's got the mounds. I heard Lake Missoula drained rapidly. Mounds don't have anything to do with that, do they? Yep, that's what I'm saying. That's what I'm saying. But did here's a question: did the California Central Valley does that also have evidence of draining just as rapidly as Lake Missoula? Yep, the exact same feature, horizontal line and mound patterns. So you can check this out when you're driving down to LA. It's quite the hillside. Okay. I'm going to just try to show you as many spots as possible in the time I've got. All this right here. Merced, all this, Red Bluff, all good stuff. This apparently reminds me of Alaska. Let's see why. Oh yeah, because Alaska's got a lot of hillsides that have this, where they do have mound separation, but they don't. A lot of them just have the curving path. Let's see if I can find that. I don't know if I got it pinned, but I bet I could find it. I think it's somewhere near Fairbanks. Okay, once we go to Fairbanks, I'll find it for you. Okay, yeah, see how it's got that all those lines. Right, so that's kind of an Alaska type of formation. But that's, obviously found all over the world. Let's go find. In the dock, I think I had this spot. Or no, I don't think I had this spot, but this one's a sick one. How did these lines get there? Are they ripples or are they eskers? Ooh, that's the question. Are they ripples or are they eskers? I think this one. Yeah, this is where I had in the dock. I think it was this spot here. Showing how there's smaller mounds around larger mounds. I guess we can see this one as well. All right, 24 minutes in and we're going strong. If you guys have learned anything or have been astonished by anything, please give me a like. All right, check this out. Terrace, mounds. You guys know the drill. Streamline formations, mounds, same thing. All right, let's go way out of town. I guess let's just go start over here. It's kind of a weird one, kind of a fluvial. You got the fluvial lobes around here. Right, water current came this way. Those aren't, I mean, it's a nice salt scabland area, but let me find some real nice ones for you. This is a cool spot. So, first of all, let me show you guys. This is a mega scale river. That's that was once 43 miles wide. It came down through here. All this sand deposit was once underwater. But after that, it went through this little narrow passage when the water level was lower. And then it, boom, made a little expansion bar right here. And that's what this feature is. This is the river bank of the expansion bar. Now, even before that, when this was all underwater, these lines coming across were an accretion ridge slash, lake shoreline or river shoreline, however you want to think of it. And then you've got ripples that ran perpendicular to the current while the lakeshore lines run parallel. That intersection made these mounds in a grid-like pattern. Okay, then you get scours, gets a little salty. All over the place it's salty. Here's a nice example of mounds. These guys are pretty big. Let's check the diameter of this guy here. This one really looks like the ones we find in Saudi Arabia, half mile. Very impressive. I mean, imagine standing on that half mile wide mound. That'd be pretty sick. I know I'd like to do that. Let's sign some more stuff. Obviously, mega scale ripples right here. I think those are about 2 miles in wavelength. Those are quite the spot. Let's go to this spot here. Yeah, this spot's actually pretty cool because first of all, we notice that the direction has a dominantly goes this way. And we can see that based upon the way the look at how this one's streamlined, right? The water went that way. So that's what all of these, this is a great way of understanding mound formation. That's a good spot. And then obviously you've got the drumlins that go parallel. Ripples go perpendicular. The messy intersection creates mounds. Okay. Here's a good example. This is a river scour, river trough. Scarp edge, nice flat scarp edge. You come in here and you get some nice mounds. I think that one was in the documentary. Now this spot I really like. We're in a nice flat basin. You can see that water poured off this way. But what's really cool is to go hide over like this. Or let me find a good spot. I think, yeah, like this here. Okay, you guys can see the ripples. Where's the best spot? I swear there's a spot. Like this. Okay, yeah, here you can see the ripples really clearly. Do a wavelength check. Beginning of crest to beginning of crest. In feet, 1,500 feet. So you've got 1,500 foot ripples. Keep in mind, a lot of the ripples in Washington are only like 300 feet. And these are 1,500 foot ripples. Then we've got drumlins, okay, parallel from the water current. Now, when the drumlins and the ripples intersect and kind of wash around each other, that's exactly what creates a perfectly circular mound. That's textbook right there. And that mound is massive. Okay, almost a mile wide. So just take that, and you kind of get like a comma shape, right, where it's kind of a directional. So you kind of see that the current direction was flowing, up the screen on this one. Yes, that's important stuff. You know what? That reminds me of Africa. Let's go back to Africa. We're going to find some big old mounds in Africa. Kind of look the same, nice and round and shallow. This guy here. Come on, give me miles. 2 miles. 2 mile wide mound. Of course, you've got salt scablands. Of course, you've got drumlins right next to them. You've got scours right next to them, circular scours. Okay, I think you guys might just figure out what's going on here. Here's a cool intersection. Okay. It's like a hashtag. Drumlins, ripples. Very cool stuff. Mesas, yes, they've got nice mounds. I think this is a good example of Mima mounds, right? That's what you call the tiny little, or pimple mounds, right? When you got tiny little pimple mounds, they're Mima mounds. All right. Little pimple mounds. Also, you got pimple mounds all over kind of the Midwest and the lower, kind of the South area. When you do, in my documentary, when I show you LiDAR imagery, there's Mima mounds all over the place here. But let's just check out some stuff like this, right? So obviously this being a floodplain, fluvial origin is strongly suggested. Where are the other? There. So you got all of these accretion ridges, and then when the water cuts in between, let me find the good one. When the water cuts in between these accretion ridges, then you have, ta-da, a mound. Diameter in feet, 84-foot mound, nice accretion ridge. In a floodplain, obviously of fluvial origin. Okay, so I've shown you mounds in Africa. I'll show you mounds in Australia too, but let's show you some nice lush ones up here in Michigan. This was in the dock. Right, nice ones. Gophers didn't build these big lines here. These are all lines that weren't washed away and carved out into mounds. So everybody's talking about, oh yeah, gophers did it. No, gophers. When you look at the detail and the shapes, now here we kind of get drumlins, which are basically streamlined mounds. I'll show you guys some streamlined mounds. You want to see streamlined mounds? I'll show you streamlined mounds. Where's the good streamlined ones at? Oh, come on, streamlined mounds. Where are you? Nope, those are pimple mounds. See, there's so many different types of mounds. Maybe it's in North Africa. Let's check out this spot here. Yep, clearly made by that river back in the day. Let's check out this spot here. That's a big old mound right there with smaller mounds in it. So let's do a little thing here. Smaller mound, tell me how big it is. 140. Let's round up, give it 150, benefit of the doubt. Get a sweeping current, looks like drumlin formation sweeping across here. Obviously ripples there, but let's just then look at, as a whole, the larger mound. A diameter of almost 5 miles. And we can see how it's a streamlined formation as well. This being the front face. and that being the tail, just like over here. And then obviously here, there was a current that actually swept across this way. And when you find these drumlins, that's the evidence for it. So I'll tell you guys a lot of crazy stuff, but it's only because, I know how to read a drumlin. It's telling you exactly where it went. And then a ripple went the perpendicular. So when you understand, two basic things, or really three, drumlins, ripples, and mounds, you can figure a lot of stuff out. Now these are one of my favorite marine terraces. And yeah, they got mounds on them. But yeah, these marine terrace sets in Libya, sheesh, textbook. Too bad it's on the front edge of a subducting plate. You know what that means? If you don't, then I'll explain it right now. So this African plate subducts under the European plate, supposedly to form the mountain ranges of Europe. So when you expect to find a marine terrace, you find them in California. Oh, well, that's because of the uplift. The Pacific crust is going under the continental plate, blah, blah, blah. Well, this plate is diving under the Eurasian plate. So how do you get these marine terraces way up here? Okay. Has nothing to do with uplift. Okay. Nothing to do with uplift. Let's go to Europe. I know this is a good spot in Europe. I believe this is Spain. Look at these current ruts on the mesas. That's why I love mesas. They've got mounds and current ruts and drumlins. And they're planed perfectly flat. See, that's why I love mesas. Real passion for mesas. Let's go to these guys here. Oh yeah. These are some nice ones. Streamlined mounds. Some would call that a drumlin. I'd call it a streamlined mound. When the tail's like that. Here's a great spot for mounds. Kind of got to zoom out to get it more clear. But yeah, you can see, if you got LiDAR of this, it would blow your mind. But yeah, these are actually all really big stuff. Like this mound here, or this guy here. Let's check the width on this guy. We could measure from here to there. Over half mile. I'm impressed. Hopefully you are too. Let's see. Britain's got some. Yeah, finding mounds in lush regions is a little bit harder because they're kind of hiding, but they're there and they're saying the exact same thing. And so, yeah, these these mounds here, they're obviously, ice sheets did that because it's so far north, but yeah, I'm not buying that. These, you can see the river separation here on these guys. And then it gets real flat up here. This is the very top of the hill. So, yeah. Let's go over to this spot. Same type of thing where you see the ravines coming up and then they carve and separate the mounds. Very cool. Let's check out, was this Sweden? Yep, they got mounds. I've seen cleaner ones, but yep. What are these, eskers or ripples? Telling you right now, eskers is a made-up word. It means nothing. Where, this one here. Yeah, we kind of get a ripple type formation. And there should be some good mounds in this area, right? These are getting more moundy. Technical term. When it gets moundy out, Ripples all over the place, mounds all over the place. They get a little bit streamlined sometimes. Come on, I know there's some good mounds up here. There they are. Textbook. Look how nice and round it is. Okay, don't say anything. Don't say it. Feet. 280 feet. Nice. Nice, brah. Drumlins, ripples, mounds. You guys get it. All right, where should I go next? Apparently this has an exclamation point. Ooh, I like that. You can really see how the current swept around. You get kind of an egg-shaped, larger mound. More streamlined mounds from the current, and then you zoom in more, smaller mounds again. And then, of course, what do we find? Drumlins, right? Parallel passive water current. Zoom out one more, and now we're talking about a megascale river. And the width on this guy in miles, 35 miles. I'll show you with topographical data. This is a 35-mile wide river, no doubt about it. Get out your topographical map if you disagree. Okay, now let's talk about some streamlined mounds. These guys are sick. Drumlins, right, totally drumlins. Here, sweeping. Get a little bit of salt remnants. You know what that means. But then when we get here, I mean, you could call that a mound. The way it's been separated and carved out around each side, it transitions from a drumlin to a mound. This one's even circular. Okay, so the mound drumlin transition. Then over here you get even more circular of mounds, a little bit of sediment lobe type formation. Right, same thing. You know, you get mounds, streamlined mounds. Nice salt scours. Nice drumlins, salt drumlins. Very low elevation. So what do you think? Was it the ice sheet or was it that salt lake? And was that salt lake once a part of the ocean when it had this massive sweeping current? These are the questions, right? How do mounds form? Did a gopher build this mound? Did a gopher terrace this mound? Probably not. All right, you guys are probably learning about mounds, but I'm going to keep showing you mounds. I don't care. Perfect circle. Look at that. Okay, maybe not perfect, but it's real nice. 650 feet. And yes, you kind of also get the ripples coming across that basin. Oh, these right here. These ones are so sick. So here, definitely call that guy a mound. Definitely call that guy a mound. But here, these are more like ripples. Okay. Get the steep face. And then you get the drumlin here, sweeping around. You see what happened here? It swept this way. And ripples, triangular shaped ones. Then you get way smaller ripples, right? Because we're talking about a decreasing current. So these ripples, compared to these ones, like 20 times smaller at least. Drumlins. You guys getting it? I know there's some sick I think this is Morocco. I think this is a sick one here. Oh yeah. These being drumlins, these being mounds. People think, oh, there's human remains, or these are maybe burial mounds. Well, because they are nice big round mounds, they could be burial mounds if they had human remains in them. And they're 60 feet across, so it's something someone could build, but they're just not. They just aren't that. I know we got some good mounds right here. These are like pimple mounds, except for they're too massive. The width on this guy here, it's a mile. It's very impressive. And I mean, these mounds, you know, the world's most widespread geologic mystery, you guys are now seeing why they're so widespread. Because the event that formed them was global. Yes. A global event of a water current did something. This one's got 2 exclamation points. It must be good. Oh, yeah. Did not disappoint. We kind of get a little bit of a comma-shaped tail on these guys. See how we can see a little bit of drumlin action. We get an idea of which way the current swept to intersect the ripples. Right, the ripples across, drumlins parallel with the current. You add them together, put them in the blender, and it's mounds every time. Just about every time. Yeah, so they're pretty widespread. They're too widespread to keep being not just a mystery, but unmentioned, right? And when you guys study all these areas, you know, maybe if I showed you guys all of these areas and I didn't even say anything, I bet you guys would figure it out. It's really not that hard. I think it's a pretty obvious mystery once you've seen them from all over the world. So that's what this video is. It's a long video, but I want you guys to stay with me till you guys see the mounds of the world, right? See the intersection between drumlins and ripples. It's not that complicated, really. And I mean, you also have to understand the magnitude too. So how big are these ripples, right? What sort of current depth and what sort of current velocity creates a big ripple versus a small ripple? Well, that ripple's over a mile in wavelength. So I'd say a big and deep current. How big and how deep? We don't need to get into the specifications. For as long as we know it's on the mega scale. And studying sheet water flow like this, check this out. Drumlins telling us the exact current direction, intersection of ripples. Drumlins again. Okay, there was one, I know there's some drumlins I want to show you. All right, let's go to this spot here in Turkey. Nice rounded ones. That's not what I was thinking of. I'm thinking of, oh, you know what I know? Let's see about these guys. Yep, more mounds on top of larger mounds, kind of like a Kazakhstan type of vibe. I think I probably have those under drumlins. I'll probably have to talk about those in my drumlin video. But yeah, there's some nice streamlined mounds. I mean, the intersection between mounds and drumlins is quite interesting. I guess I'll talk about that in my drumlin video when I show you guys the drumlins of the world. Right, we got mounds on these terraced hills up here in Somalia. All these terraces indicate water level. All of the mounds indicate water level. The fact that these are lined up level on the terraces indicate lakeshore lines, indicate accretion ridges, indicating water level. What's the altitude? 1,800 meters. Yeah, that's a nice marine terrace. So marine terrace, marine terrace, marine terrace, marine terrace, marine terrace. No, that's a mesa. Yeah, what do you think a mesa is? Marine terrace. Mounds, marine terrace. Pretty fascinating stuff. And they say the Grand Canyon's only in Arizona. Not exactly the case. Here's a good example of seeing how the mounds form. Okay, now I think I'm getting the streamlined ones I was thinking for. See how these guys are kind of streamlined? That one's not very good. Where's the good ones at? Mounds. Nice. These are nice rounded ones. Now they're getting a little more pointy. These are kind of like drumlins, right? Kind of like the ones I showed you in Russia, Kazakhstan. Hmm. Oh, this one was in the dock. This is a good example. I mean, this got to be the best example. I mean, you go here. Obviously, these are mounds. Obviously, those are river um, ravines, right? Braided ravines off of this hillside. And you're going to tell me gophers made the mounds? Is that what you're going to tell me? You're going to tell me ice sheets made mounds? Because, you go to Washington, they tell you, oh, the ice sheets made these mounds. You go to Ireland, you go to Scotland. Oh yeah, you know about these ice sheets? We can actually track how the ice sheet moved based upon the mounds and drumlins. Oh really? You're not tracking ocean currents by chance? No. Okay. All right. I believe you. No, I'm gonna find some more. I think you know what I know where they are. Now this one actually. There are some really nice mounts here, but the update put them underwater, unfortunately. But let me show you nice ones down here. This was in the documentary. These mounts here. This is Mozambique. Yeah, this spot here. There's nice mounds around larger mounds. You get that nice egg shape. This is a perfect egg. Cook it for breakfast. Because you get the layers, because this is a ridge here. A terrace, if you will. That's what makes the egg shape, is water levels making a terrace. And then, of course, mounds, smaller mounds, subdividing. Right? How did these mounds form? That's the mystery. Nobody knows. But now you guys know, and I've shown you so many spots. I mean, I've spent hundreds of hours finding mounds from around the world. And now you guys know all of the spots I've found. And you guys can now show them to, your teacher, your friends. get some understanding. Check them out for yourself. So it's not only a widespread geologic mystery, but it's a mystery you guys understand now. I'm just going to keep going until I've shown you all my mounds. Oh, I haven't even gone to Australia yet. Damn. Let me go to Australia. Let's look at all these mounds. In a nice salt scablands, bigger mounds here. Some bigger mounds there. Smaller mounds around them. Obviously, there's a decent current in that area. Let's check out these. Oh, this was in the documentary. I talk about mounds being on a strange landform. The strange landform I was talking about is you've got mounds around these parallel ruts, right? See how these are scours, right? So you've got mounds on drumlins. You've got mounds on parallel ruts. Anything parallel, whether it's a mound or a scour or a drumlin or a scour, it's indicating a sheet water level or a sheet water flow, right? That shows parallel, right? You guys already know that, but I'm just say it anyways. Here we get kind of a nice little, you might call that an esker formation if you were indoctrinated by Ice Age theories. Nice ripples with the mounds. Fluvial fan deposit. That's pretty cool. I like that. It's a nice fluvial fan. Oh, this is cool. I like this one. These are fluvial lobes. Show current being pushed down. Same direction as how this sedimentary deposit was pushed down. So when you get a feature that tells you current direction, that's always interesting. Because sometimes the current directions switch or are something really odd. No shortage of drumlins and mounds around the world. All right, let's zip over to Africa, or excuse me, Australia. Now this whole area here, this entire area, it's all mounds. All mounds. Let's get a little thing going on. You can see it's kind of a lower elevation within like a marine terrace. I'm kind of following the marine terrace. And in miles. Yeah, over 1,000 miles of mounds. Just zoom in anywhere there's mounds. Doesn't matter where you go, you're gonna find mounds. But this, I think I had this shot in my documentary. Here, oh yeah, look at that. Flows right into a little drumlin-like formation. Very faint, but you can still see it. Oh yeah. Oh yeah. It's good stuff right here. Good stuff. Oh yeah, these are some nice pointy ones. These were getting a little more drumlin-y. Now this is a great spot. This reminds me of a spot I showed you in Ireland, and also a spot in China. Obviously, coves are made from uh, water flowing offshore. So many drumlins in Australia. It's amazing. I love it. Nice big mounds here in this salt pan. Right next to drumlins, of course. Some little mounds there. With a lot of current ruts on this landscape. See all this rutting? Most of these ruts are parallel. That's because of sheet water current. Right. But very chaotic since there's all these, cross sections. Let's go. Here's a spot that's kind of hard to find, but I believe this is Southwest Asia. Even a hillside that's just fields, you can still see the mounds. And if you had LiDAR, if you had LiDAR, all of this stuff would pop out really easy. But even with just Google Earth, you can be like, hey, you're a mound. I see you. Where's another one? All right. Again, mesa, mounds. A lot of ravines around here. Kind of like Washington. So people talk about Washington like it's something special. I mean, you got Southwest Asia doing the exact same thing. So it's like name a spot that's not like Washington. Go to Sri Lanka. Mounds. Low elevation, high elevation. Really doesn't matter. This one's called O. Let's see what's going on. Oh, yeah. These are cool. They kind of got water currents that washed around and sculpted them out. Those are really cool. Kind of like an egg-shaped formation, but different. And then you got ripples here. But I'm pretty sure these are pretty large ones. Let's see. Yeah, over a mile. Not too bad. And then, of course, I don't even gotta say, they're drumlins. Got the mounds. I already showed you that spot. I think down here there's a cool spot. Oh, where is it? Oh, yeah, here. You got all these little guys. .5 miles. But these look really tall. Look how tall these things are. Probably over 100, 200 feet tall. And then that's nothing compared to these ripples, which are 2 miles in wavelength. So basically that's it. That's basically all the mounds. Thanks for watching, and stay tuned for more features. I'll show you, vast amounts of evidence for all sorts of other features around the world. And like, subscribe, comment. You want me to find a mound near you? I can do that, no problem. So thanks for watching, and I'll see you guys next time. And yeah, that's it. Thank you guys. All right, bye.